Hello and welcome to our GNR 638 project Neural Super Sampling. Let us see the problem statement. Let's say we are given an image of some size. We want to upsample it 4 times in height and 4 times in width, thus making the number of pixels 16 times to that of the original image. Why is this important? Upsampling is used by various companies to increase the quality of videos and images. Notably includes Disney, which uses in its animation videos, and Nvidia uses it to improve the gaming experience. Three possible solutions exist to this problem. First, using interpolation. Libraries like OpenCV has inbuilt function for resizing the images. If we try to upsample images using it, it uses interlinear interpolation technique. This technique is very inefficient. It creates a lot of blurriness in the upsampled image. Second, using autoencoders. Encoders take low resolution image as input and the decoder outputs the high resolution image. This technique is good for upsampling a factor of 2 but not very efficient for upsampling factors greater than that of 2. Third, using GAN. Rather than feeding noise to GAN, low resolution input is taken as input and upsampled image is the output of the generator. It works good for most of the upsampling factors. This project will focus on upsampling using GAN. SR-GAN is one of the architectures which gives very good output for upsampling. It is based on 2017 CVPR paper using GAN for image super resolution. As shown in this image, the architecture mostly consists of residual blocks and then followed by an upsampling layer. In this project, we have used 8 residual blocks. Let's see about the generator and the discriminator. First, about the generator. Generator takes in low resolution images and outputs the upsampled image. The generator loss function tries to minimize the difference between two high resolution images. Discriminator tries to tell if the image is upsampled or is a high resolution image. Let us see some of the details of the training. Training data consisted of 8144 images taken from Kaggle. Low resolution images were created in OpenCV's interpolation technique CV intercubic. Number of epochs were 1000. Loss for discriminator was binary cross entropy. Optimizer used was RSMP prop and was trained using Keras with TensorFlow as backend. Now let us see the testing algorithm. Consider if we want to upsample image of size 150 x 125. First, the algorithm would resize it to make it a square of the size of which has the lowest height or width. In our case, it would become of size 100 x 100. Then the output image is initialized. In our case, the size is 400 x 400 and the patches of 24 x 24 are used to iterate over the entire image, and the output of the size 96 x 96 are saved at the corresponding location in the initialized output. And we are now set to go. Let's see some of the results. This looks to be working great, but if the input itself is of high size, then the output is not very good. In this image, if you see clearly at the bottom, there are unnecessary pixels or some unclarity. Thus, we need to improve our model. Improved version of SR-GAN. SR-GAN is a famous paper and there are various improvements possible to this architecture. We will focus on the one which is given in the paper ESR-GAN. We do the Two things. First, remove batch normalization layers from the generator. And second, we replace residual blocks with residual in residual blocks, and rest of the architecture remains the same. The paper ESR GAN has suggested some more changes, but we will do only this too. Details of the training. The training details are same, but only the number of epochs are increased. Now we can clearly see that there is no blurriness, which we got in the case of SRGAN. Hence, our project is completed. Let us compare some of the results. If you observe in SRGAN, there is some sort of unnecessary patches, the white color patches, which are not necessary. But in the improved SRGAN, the image is very clear, and thus improved SRGAN is better than SRGAN. Some of the references. And yes, that was it. Thank you from Omkar, Achintya and Aryan.